Hi, we're going to start off here by doing some centripetal acceleration problems. These centripetal acceleration problems come from the Crim Physics website underneath the centripetal force and gravitational chapter. The first question says a rope attaches a tire to an overhead tree limb. A girl swinging on the tire has a centripetal acceleration of 3 meters per second squared. If the length of the rope is 2.1 meters, what's the girl's tangential speed? Tangential speed just means linear speed. It's just velocity. And so when we are doing this problem, this is a very straightforward problem. We write down our data. The centripetal acceleration is equal to 3 meters per second squared. The radius is equal to 2.1 meters, and we're looking for v. And so using our centripetal acceleration equation, v squared over r is equal to centripetal acceleration. We have two of the three variables. We would have something like is equal to get this back. The computer just jumped on me here. Centripetal acceleration of is equal to v squared over r, which then means that we would have 3 is equal to v squared over 2.1. So v is equal to 3 times 2.1. We're going to take the square root of that. And so when we plug that into our calculators, we end up with 2.5 meters per second. There we go. That's question 1. Scrolling down, we're going to look at number 4. A car moving along a circular track has a centripetal acceleration of 15.4 meters per second. If the car has a tangential speed of 30 meters per second, what's the distance between the car and the center of the track? So you could imagine, this is what we call a flat curve. You could imagine a curve, car traveling along, it's going around that curve. And again, we know that the acceleration is equal to 15.4 meters per second squared. We know that the velocity is equal to 30.0 meters per second, and we know that we're looking for r. Centripetal acceleration is equal to v squared over r. So 15.4 is equal to 30 squared divided by r. So r is equal to 30 squared divided by 15.4, which is equal to 30 squared divided by 15.4 gives us 58.4. There we go, 58.4 meters. Nice. And the last problem we're going to do, which is going to be the hardest of the set, is going to be this one about a cement mixer. A cement mixer has a radius of 2.5 meters. And so R, that one's pretty straightforward. R is equal to 2.5. But it then says that it turns with a frequency of 0.02 hertz. That's not something we've seen here. We did see this earlier. What's centripetal acceleration? So we know that we are going to be looking at acceleration is the question mark. So we need to be able to find v. And so we know the frequency is 0.2. So we should be able to find omega. So in this particular case, this might be one where it makes a little more sense to use the centripetal acceleration equation, which we saw which I showed you earlier, which was that centripetal acceleration is equal to omega squared r. That's one way of approaching this. Or we can use the frequency of 20 hertz, use that, find omega, solve it for v, plug it in. Your choice how you want to do it. I'm going to use omega here. So we know that omega is equal to again, there's a little bit of a lag in my pen with Screencastify. Omega is equal to 2 pi divided by the period, or that's the same as 2 pi f. And we have the frequency. So ultimately, what we're going to be able to do here is we're going to be able to figure out the centripetal acceleration from the fact that we know that this is going to be 2 pi times 0.02. This whole thing is squared times that radius of 2.5. And so when we put that in there, we end up with 2 times 3 times 0.02. We get the answer there. We square it, and then we multiply that by 2.5, and we get a centripetal motion here of 0.039 meters per second squared. There you go. If you have any questions, don't hesitate to ask. I will be doing some problems on centripetal force next.